Hello students. Till the previous session, we have seen about molarity and different concepts of molarity. In today's session, we are going to start a new concentration term which is molarity. Okay, only one letter difference. Molarity was R-I-T-Y. Molality is L-I-T-Y. Now, let us try to understand what is molality. Number of moles of solute in 1 kg of solvent. How many number of moles of solute are present in 1 kg of solvent? When you go back to molarity, then what was the definition? Number of moles of solute per liter of solution. Here it is number of moles of solute in 1 kg of solvent. In molarity, we were talking about solution, volume of solution. In molality, we are talking about mass of the solvent. Okay, how to write this in terms of formula? Okay, molality is represented by small m. Molarity was capital M. Number of moles of solute divided by mass of solvent in kg. Okay, this is how you calculate molarity. Now to understand molality even better, let us take a small example. If someone says 4 molar NaOH, what does it mean? What does it mean? It means that 4 moles of NaOH present in 1 kg of solvent. Let's quickly recap molarity also. If someone says 4 molar NaOH, what did I say? 4 moles of NaOH in 1 liter of solution. Now here, when someone says 4 molal, how do you pronounce molal? If you want, you can write here. If someone says 4 molal NaOH, what does it mean? 4 moles of NaOH present in 1 kg of solvent. Now, what else I can get information from this data? Let us see. Because if someone says 4 molar NaOH, is this the only data can we get from it? No, we can get a lot more information only from this simple term. Lot more information we will try to collect. What information we already got? Number of moles of solute, 4 moles. Okay, this is number of moles of solute. Mass of solvent also we got, which is equal to 1 kg. What else can we get here? Can we get mass of solute from here? Let's try. Can we get mass of solute from here? Can we get mass of solution from the given data? Only from this particular part, 4 molar NaOH, we already know number of moles is equal to 4 and mass of solvent is equal to 1 kg. Can we also try and find out mass of solute and mass of solutions? Let's try. Mass of solute, I am trying to find out. What is solute here? NaOH. Okay, NaOH is my solute and 1 kg is the respective solvent we are taking. Usually we take water. Okay, mass of solute. Because it is NaOH, how can I do? Number of moles of NaOH is equal to mass of NaOH, which is my solute, divided by molecular mass of NaOH. Now, do I have number of moles of NaOH in the question from the given data? Yes. So how can I calculate it? Just cross multiply. Mass of NaOH is equal to number of moles of NaOH into molecular weight of NaOH. Number of moles of NaOH into molecular mass of NaOH. How much do you get? 4 into what is molecular mass of NaOH? Now I already many times calculated and I have shown you. It is 40. That is equal to 160 grams. So what is the mass of solute I got from the given data? I got 160 grams. So I have calculated mass of solute. Now let me try and calculate mass of the solution. Now how can I get mass of the solution? Mass of the solution is equal to mass of solute plus mass of solvent. Mass of solute plus mass of solvent. Do I have mass of solute here? Yes, I have just found out mass of solute. How much is it? 160 grams plus mass of solvent I already have from 4 molar NaOH data, which is 1 kg. But because here mass of solid is given in grams, I will just convert kg into grams. So how much I will get? 1 kg is 1000 grams. So just add 1000 grams plus 160 grams, you will get mass of the solution, which is 1160 grams. Clear? So only from the given one small data, 4 molar NaOH, I could get the number of moles of solute, mass of solvent, mass of solute, and mass of the solution. This is how in the question you need to try to identify the things from the given data. Don't think that he has just given 4 molar NaOH, he didn't give anything, he is asking us to find so many things. No. Okay, from this you can interpret so much data, just you should know how to approach it and get the required data from what he has given in the question. So this is how you should understand molarity. Now to get a better understanding of molarity, let us solve numericals. Let's start solving numericals. 4 grams of NaOH is added to 100 ml of water. Calculate the molarity of the solution. Density of water is equal to 1 gram per ml. So first let us write the molarity formula. Number of moles of solute. What is the solute here? NaOH divided by weight of solvent. Divided by weight of solvent. Okay, here what is the solvent? Water. Okay, we will write the weight in kg. Okay, so this is my formula. What do I need here? I need the number of moles of NaOH. Is it there in the question? No, so we need to find the number of moles of NaOH. Then we need to find the weight of the solvent, which is water, in kg. Is weight of solvent given in the question? No. They have given us volume of the solvent, but they didn't give us mass of the solvent. So we have to find the mass of the solvent. Because we have density of the solvent, which is water, we can easily do that. Okay, first let us calculate number of moles of NaOH, which is my solute. Okay, we'll calculate number of moles in terms of mass. Given mass of NaOH 4 divided by molar mass of NaOH, which is 40. So 1 by 10, that is equal to 0.1 moles. In the similar way, let me calculate weight of solvent. Okay, let me calculate weight of solvent. I don't have weight of the solvent in the question, but I have volume of the solvent. So how can I calculate it? I have the density of solvent water, which is 1 gram per ml. We know the formula. Density is equal to mass divided by volume. So density of water is equal to mass of water divided by volume of water. Density of water is how much given? 1 gram per ml, which is equal to mass of water. We need mass of water only. Where solvent is water, we need weight of solvent. So I need mass of solvent, which is water, divided by volume of water is how much? 100 ml. Okay, now if you calculate it, what will be the mass or weight of water here? 100 grams. So what is weight of the solvent here? How much I got? Weight of the solvent is equal to 100 grams. But I need it in kg. So what will I do? I will convert 100 grams into kg, which is equal to 100 divided by 1000. I am converting 100 grams into kg, so I am dividing it with 1000. So what will be? It will be equal to 1 by 10, that is equal to 0.1 kg. Okay, so I got my number of moles of the solute NaOH 0.1 moles, and I got weight of the solvent, which is 0.1 kg. Now can I substitute them here? How many number of moles of NaOH I got? 0.1 moles. How much amount of weight of solvent I got here? 0.1 kg. Hope you understood how did I get weight of the solvent. I have density of the solvent. So density is equal to mass by volume. I have substituted density. I have substituted given volume of water. Then I got mass of the solvent, which is 100 grams, which I converted into kg and substituted here. So that is equal to 1 molar. Okay, so these are the types of questions which you get from molarity. Now, when we were doing molarity, we did a question, calculation of molarity of pure water. Then I clearly told you how much ever you take the amount of water, the molarity of the pure water will always be 55.55 molar. Now, let us come to molality and let us try to find the molality of pure water and 1000 grams water. Why are we calculating it for 1000 grams? because 1000 grams is equal to 1 kg. When I was defining molality, I clearly told you what is molality, the number of moles of solute present per kg of solvent. So per kg of solvent, here my solvent is obviously water usually, because we do questions only with the aqueous solutions. So I am taking 1 kg water, so that is my 1000 grams of water. So let us try to calculate molality of pure water, which is 1000 grams of water or 1 kg of water, because in the numericals we always take 1 kg of the solvent. Our solvent is usually water. So find the molality of pure water. So what is the formula of molality here? Number of moles of solute divided by weight of solvent in kg. Weight of solvent in kg. Now here, when I talk about pure water, when I was teaching molarity, I clearly told you, in these cases we consider both the solute and solvent as water only. First, let us calculate the number of moles of solute. Number of moles of solute is equal to given mass divided by molar mass. So here my solute is pure water only, because whenever I am talking about pure water molarity and molality, I take both the solute and solvent as water. So number of moles of solute, what is my solute here? Water. Number of moles of solute is equal to given mass is 1000 grams divided by what is the molar mass of water? 18 grams. Few values you have to remember so that you need not waste time calculating them again and again. This calculation we did when we are doing molarity calculation to 1000 by 18 is how much? 55.55 moles I am getting here. Okay, so these are the number of moles of solute I am getting here. In the denominator, what do I need here? Denominator, I need weight of the solvent in kg. Now, because whenever I take molarity and molality of pure water, I told you we take both solute and solvent as water. So my solvent also here will be water. So my weight of solvent is equal to, in the question, the weight of water is given, which is 1000 grams, which is equal to 1000 grams, but I need it in kg. So 1000 grams, I can write it as 1 kg. Now if I substitute in the molality formula, number of moles of solute is 55.55 number of moles divided by 1 kg. Okay, so what will be my answer? Molality is equal to 55.55 molar. Now if you are getting it out, should we write only molar? Ma'am, doesn't molality have a definite unit? Yes, molality will definitely have a unit. So how can I get the unit for molality from here? Number of moles of solute, how do I write? Moles, okay, divided by weight of solvent in kg is your kg. Okay, so if you want to write in terms of literal units, you can write molality is equal to 55.55 moles per kg. Okay, here also you can write what is the molality? Molality of solution is equal to 1 mole per kg. Either you leave it writing molar, or what will be the unit? Moles per kg. What was the unit for molarity? Moles per liter, because there we are talking about volume of solution. Here it is kg, because we are talking about weight of the solvent. So here this is about the numericals regarding molality. Now we'll see a very small concept of the temperature dependence of molarity and molarity. Do these two concentration terms depend on temperature? If yes, why? Let us see the temperature dependence on the both concentration terms we have seen, molarity and molality. Okay, what do I mean when I say temperature dependence? It means that if I alter the temperature, will the molarity of the solution change? Or if I alter the temperature, will the molality of the solution change? Let us see. Now if you see the formula, molarity is equal to number of moles of solute divided by volume of solution in liters. Now here if you see, if I change the temperature, the volume of the solution will get affected. Okay, if I increase or decrease the temperature, the volume of the solution definitely will get affected. Now when you come to molarity, the mass of the solvent will not get affected by the temperature, because when I say the solvent is water, the mass of the water here always will be constant. The mass of the solvent will not change. You cannot alter the mass by changing the temperature. Am I right? You can't change. For example, if I have glucose, I can't keep on changing the mass of glucose by altering the temperature. So here I cannot alter the mass of the solvent by changing the temperature, but I can definitely I can definitely make a change in the volume by increasing or decreasing the temperature. So from now, because we have even more concentration terms coming up, always remember this concept that whenever we are talking about volume in the concentration term, temperature will definitely show its effect on it. As long as the formula of any concentration term doesn't have the term volume, it is temperature independent. So here molarity is temperature dependent concentration term, whereas molality is temperature independent concentration term. Okay, so this is what you need to understand. Not only for molarity, and molality, when we are going to do further the concentration of more fraction, percentage composition, okay, ppm, ppb, always remember if you are getting volume in the formula, then it should be temperature dependent. If not, it will be temperature independent. So this is about the dependence of temperature. Okay, so hope you loved today's session. I explained you what is molality and how to understand molality, and we try to solve few numericals and molality, and then the temperature dependence on the both the concentration terms we have seen, which are molarity and molality. Hope you loved the session and understood the session. I'll see you in the next class with a different concentration term. Till then, see you. Bye bye.